The James Webb Space Telescope has seen something that no one expected. Something faint, something deliberate, something glowing on a world just beyond the boundaries of our own cosmic neighborhood. From a distance of just over 4 light-years, tiny pulses of infrared light seem to rise from the night side of Proxima Centauri b, our nearest exoplanet neighbor. At first, the data looked like noise, a technical quirk, a simple anomaly. But then the pulses appeared again. And again. Structured. Rhythmic. Steady, as if following a pattern that nature itself rarely produces. Scientists quickly ruled out the usual suspects. Not auroras, those are wild and chaotic. Not flares, not volcanic lightning, not reflections from ice or dust. Whatever this light is, it doesn't behave like something born from geology or weather. It behaves like intention. Proxima Centauri b orbits a small red dwarf star in the Alpha Centauri system, the closest star system to our own. It sits in the star's habitable zone, a fragile region where liquid water could exist. For decades, it has been the quiet hope of astronomers, the place where, if life exists anywhere close to us, it might be found. But Proxima b is tidally locked, with one hemisphere locked in eternal day and the other frozen in endless night. If anything intelligent lives there, survival would demand creativity. Perhaps even technology. Perhaps illumination. Webb's observations show a faint, persistent glow spreading across the dark side of the planet. Not in a single burst, not in random flickers, but in a stable sequence. Light rising and falling with a cadence that almost feels alive. If you were to hover above Earth at night, staring down at glowing cities, the image would not be entirely different. Clusters of brightness, dimming and brightening as if responding to cycles or energy grids. Researchers like David Kipping warn the world to stay cautious. Extraordinary claims demand extraordinary proof. But at the same time, they admit the data is compelling. Too orderly. Too quiet. Too engineered. As the glow raised questions, another discovery arrived: strange atmospheric chemistry. Webb detected elevated methane but surprisingly low carbon monoxide. On Earth, this combination is rarely produced without either biology or industry. Natural processes alone struggle to explain it. Something on Proxima b appears to be maintaining this unusual balance. And scientists cannot ignore what this might mean. Perhaps life thrives there. Perhaps life has advanced. Some have even suggested that the lights could be something more than illumination, maybe signals. Beams of energy modulating in infrared, projecting a message outward. A civilization might choose infrared over radio for its efficiency and ability to cut through interstellar dust. And if Proxima b's inhabitants mastered the dark side of their world, directed light would be a powerful tool, both for communication and survival. Of course, we cannot jump to conclusions. There are natural possibilities left to explore: thermal emissions from exotic minerals, unexpected chemical reactions, geological fluorescence. Yet each alternative becomes harder to defend with every new scan, every repeated pulse. The universe just became a little less silent. A little less empty. And a little more mysterious. If these lights turn out to be artificial, it would mean that the closest alien civilization isn't thousands of light years away. It could be right next door, on a planet so close that our great-great-grandchildren might one day stand on its surface. For now, Webb has given humanity a question, not an answer. A glimmer of possibility shining from a world we've never seen, but suddenly cannot stop looking at. Whatever those lights are, they have changed the way we look at Proxima b forever. Imagine a world locked between eternal day and everlasting night. On one side, a blazing crimson sky scorches the land under a red dwarf star. On the other, an endless frozen darkness stretches out like an ocean of black. This is Proxima Centauri b, the closest exoplanet to Earth. And it is on this shadowed hemisphere that the James Webb Space Telescope has found something astonishing. A glow. A pulse. A quiet whisper of light where there should be only darkness. At first, researchers assumed the readings were artifacts. Webb is incredibly sensitive, capable of detecting heat from worlds billions of times fainter than their stars. But when the same pulsing pattern repeated during multiple observations, even the most skeptical astronomers leaned forward in their seats. This wasn't simple noise. This wasn't a flare from the parent star. This was coming from the planet. Across the night side of Proxima b, a faint grid-like pattern appears to shimmer, dim but consistent, as if entire regions brighten and fade in unison. Compared to Earth, it resembles the delicate sparkle of continents lit by cities at night, seen from orbit. The pulses keep to a rhythm, lasting the same duration, echoing the same intervals, refusing to behave like randomness. Scientists don't see chaos. They see control. Proxima Centauri is a violent star. It frequently unleashes massive storms of radiation. Any advanced species living under such conditions would need extraordinary engineering just to survive. They might build domed habitats, underground networks, or vast shielded megastructures. Or, if the dark side of the planet offered protection from stellar flares, they might turn it into their home. A world lit by artificial illumination, buzzing with energy, producing a glow faint enough to be lost in space, unless you had the James Webb Telescope staring right at it. Atmospheric readings strengthen the mystery. Excess methane combined with very low carbon monoxide is difficult to explain through volcanism or chemistry alone. On Earth, this combination often points to either life or industry. Something on Proxima b is actively shaping the air, pushing the atmosphere into a composition that shouldn't naturally exist. But maybe the light isn't coming from the surface at all. Some scientists propose orbiting satellites, solar reflectors, or giant light-collecting arrays. An advanced civilization might harvest every photon from the star-facing side and redirect it to the darkness. They might be illuminating their world on purpose, not for signaling, but for living. And yet, the idea of communication refuses to leave the discussion. What if the pulses are intentional? What if they are not illumination, but a beacon, a cosmic announcement designed to be noticed by anyone with eyes capable of seeing in infrared? Radio waves have long dominated SETI searches, but infrared is a frontier we are only beginning to explore. Perhaps aliens have always been using it. New observatories will soon join the search. The extremely large telescope in Chile, with a mirror nearly 40 meters across, will study the atmosphere of Proxima b in unprecedented detail. NASA's Future Habitable Worlds Observatory could bring direct imaging to a level Webb cannot reach. One day, a starshade may allow us to view Earth-like planets as separate points of light, no coronagraph required. If the glow is natural, then Proxima b holds geological secrets we've never imagined. If the glow is artificial, then humanity stands on the brink of its greatest discovery. Not a distant galaxy. Not a radio whisper. But a neighboring world glowing softly in the night. Perhaps they already know we exist. Perhaps they've watched Earth brighten over centuries as our cities spread across continents. Maybe, just maybe, both civilizations are staring at each other across 4 light-years of darkness, waiting for the other to make the next move. Whatever the truth is, the faint lights on Proxima b have turned a distant exoplanet into a cosmic conversation. A conversation